Hey everyone, welcome back to my channel EduVibe. Today we will start with another topic of chemistry, which is very relevant chemistry of the metal and the chemical bonding. So we will do today the electron dot structure. As I told you in the previous lesson that we now going to the original diagrams where we can transfer the electrons in this electron dot diagrams and we share the electrons in covalent bonding, which we discuss later in lessons now. So we will now start with the unit of we start with the half part we already done, and then we'll move on to the next half part, which is like a more theoretical part and more like the diagrams we have to make, and we have to know some theory at the last. So let's discuss what are electron dot diagrams and how can we make this. So this is again the topic of ionic bonding. There's a theory of ionic bonding based on that theory. So in this, and later on we will discuss the Lewis symbols. So electron diagrams also called the Lewis symbols. So Lewis symbol is named after the name of the someone named called Lewis. So it's the structural representation of the location of the valence electrons in the atom or ion. We discuss the atoms and ion the same time in this, and how they transfer their electrons to the another ion bond. So the element symbol is written to represent the nucleus and any filled energy levels below the valence shell. So these are some rules to know, that we have to make the element symbol and the written the represent the nucleus and how many energy valence levels they have filled. Each of the four sides of the symbol represents an orbital. So we know that the four sides of the symbol called the orbital, where we make. Electrons are represented with dots that surrounded element symbol. So it's electron dot. This is dot diagrams. So we have to represent those electrons through the dots by the surrounding of the element symbol. The square brackets are placed around the ions and change is written on the outside. So if we have any change, like we lose or we gain anything, so we put the square brackets around the ion and we put that what's change in this of this particular element. So one thing note over there, that cations lose electrons, so will not have any other electron dot diagrams, and the ions gain electrons, so will show the complete valence shell in the electron dot diagram. So if the cation lose electrons, so will not have any. We have to show that this will not have to show anything in the electron dot diagram. But if we have ion gain electrons, so we have to show complete valence shell of this with their electron dot diagram. So how this works and how do we do this? So we do this by some examples. So you can more clarity of this topic when we move on to the some examples. When you know that how can this works, so you can more relate to this theory part which we discuss now. So we have magnesium chloride. We have to make the electron diagram for this. So every time when we got the electron dot structures to make, so we get one the cation and other the anion. So like we write one the positively charged and one the negatively charged. So in this we have the magnesium is positively charged, so we have Mg. So we have to have made their element symbol, and plus they make Cl. So what is the formula for MgCl? Firstly tell me. So we have Mg2 plus in this and we have Cl minus of this. When we made the formula, so we get MgCl2. So when that Cl is 2, we have a Cl of 2. So we have to make that Cl2 we have. So I have to make that 2. Now, how many valence shells they have? Valence electrons they have magnesium. So if we know that how many protons they have. So magnesium has protons of 12. So I have to make like orbital diagram for this. So orbital diagram will show that this leave with the 2 at the end. So we have the valence electrons of 2 in magnesium. So I have to make that, show them in the dots like this. For Cl, Cl has a 17 protons. So at the end, they left with 7 of them. So how can we draw that 7 on that Cl? So we start from here. So 1, 2, 3, and 4. Again, 5, 6, 7. So we complete with 7 now. Here we left with 2, here we have 7, and we made that. Now what they make after this? They have to make. So you know that if the magnesium has 2 of them, and magnesium need 6 more to that stable, because we have to stable them, we have to valence electrons of 8 if we want the octet rule, if we want the stable octet one. So if they want to have gain, though if they want that 6 electrons, so they will add more type of energy, more amount of energy they want, but they don't have. So if they lose that those electrons, if they lose that those electrons and this one gain those, so what will happen? So this will have now 7 of them. So this will have 7 of them. If one of this electron left to this Cl, so this will become stable, and this will left with only one of this. So this didn't didn't affect anything, but this left with only one now. But we know that Cl has 2 of this, so this is 2 Cls. So we have 2 Cls. This means if we raise that 2 and we made one more Cl, that we have these 2 Cls. So if that one electron of this transfer to this and one electron of this transfer to this, so there's an effect. So this means that Cl loses that dose. So this means now as the result we get the square bracket we have to make Mg that positive charge because they lose those, and Cl get the negative charge. Why the negative charge? You know this will be the 2 negative, but we have 2 Cls. Like MgCl2 we have to left in this form. So we have 2 Cls. So they complete their all the shells. They complete their electrons. They complete their valence electrons in the valence shell with 8 of them. And they left with 0, which is didn't matter. They have to lose them to get the to more that not left with 2, so they have to lose them to the Cl. So that's how this is look alike. MgCl2 is look like this when we made the electron dot diagram for this. So that's how it works. So you get more clarity if we do a sodium phosphide. So sodium phosphide, if we know the formula, this is Na plus and phosphide is P3 minus. This is the polyatomic ion. You can find this on your polyatomic ions just above the periodic table on the first page of your data sheet. So this is NaP3. So this made the formula of Na3P. So how it made? So we know that Na has valence electron of 1 because Na has 11 of them, 11 protons, and that P, which is the phosphorus, this is 15 of them. So they have 5 in there itself. So plus, so 1, 2, 3, 4, 5. This is, we have 3 of them. Or if we don't want to write 3 like this, so we made 3 Na of there. Okay. So now again, this have 1, this have need how many? 3 of the electrons, so that's stable to get the 8 one. And that 3 get from here because Na wants 7 of them, which is not possible in case of Na, which is sodium. So they transfer all these electrons to their phosphorus. Like they get those and put over there. They give, put over there. This and put over there. So all the things all the electrons they give to the phosphorus, and what they make. So Na get the charge of, they have 3 and the charge of positive, and that P dot stable now. 2, 3, 4, 5, 6, 7, and 8, and they're stable by 3 negative because they gain those 3 electrons from the sodium. So that's how you can make the electron structure for sodium phosphide. This is again the same which we discussed in magnesium chloride. That's all for this lesson, the electron dot diagrams. In the next one, we'll discuss some properties. This is such a small topic in this unit, which are the properties we have to discuss of ionic bonding. So we will discuss in next lesson. So if learning made simple with EduVibe, learn smarter but not harder. If you have any questions, let me know in the comment section. Please like, share and subscribe to my channel. See you in the next lesson. Till then, stay connected with EduVibe.